All right, guys, so just like on all of the other graphical analysis problems that you generally see on the test, this problem is supposed to be done without a calculator. And so other than that, let's just dive right in and let's see if we can make sense of all of the things that we're being asked to do. So here we go. We've got a graph here. It says let f be a continuous function defined on -4 to 3, whose graph, consisting of 3 line segments and a semicircle centered at the origin, is given above. So it's basically just telling you, we're looking at this picture, this indeed right here is a semicircle, and then I got 3 line segments. Then it says let g be the function given by g of x equals the integral from 1 to x of f of t dt. Now, anytime we see that, that's automatically, almost 100% guaranteed, we're going to be asked a bunch of questions about g. So we might as well state the relationship between g and f. And it's almost always, if I take the derivative of g, what I get is f of x, and that's due to the first part of the fundamental theorem of calculus. And in general, on problems like this, if you write that down, they'll give you a point just for pointing out, I am indeed looking at a graph of the derivative. Don't assume that they know that you know that. Instead, write it down, and that will help you an awful lot in these situations. So let's go ahead and take a look at letter A. Now, letter A says find the value of g of 2 and g of -2. What this is really asking me to do is look at my g function, and everywhere I see x, put in 2. So I've got the integral from 1 to 2 of f of t dt. Well, that is just asking, this is a graph of f, so that if I'm going from 1 to 2, that is asking for the area of that little triangle right there. So that's 1/2, base is 1, height is half in this case, and it's below the x-axis, so I get negative. Because it's below the x-axis, and I'm all done with that. If you want to simplify it, -1/4 is totally fine. If we're looking at the integral from 1 to -2 of f of t dt, what we have to look at, there's a couple different things that we should probably do. First of all, we should probably switch this, so it's going from -2 to 1, but when we do that, that means that I put a negative out front. So I'm going from -2 to 1, so I'm looking for this area right here, this big triangle, and then the semicircle, and then we're going to add those two together and make them negative, okay, because of the negative out front. So my triangle, I've got 1/2, the base is 1, the height is 3, and then I'm going to subtract off the semicircle that I have. That is 1/2 times pi times r squared. The radius is just 1 here, so I get 1 squared. And I'm going to make all of that be negative because we had to flip the integral. If you simplified that just a little bit and distributed the negative, you get pi halves minus 3/2. You don't have to. This answer suffices on letter A. On letter B, it says find g prime of 3 and g double prime of 3. For g prime of 3, that's like saying, okay, remember, g prime of x is equal to f of x. So in reality, this is like asking, what is f of 3? And that just says, look at the graph and tell me what the y value is when x equals 3. Okay, so I look at, it's -3, excuse me. So I go over here and I look at -3. All right, those should be negatives there, I apologize. I look at -3 and I can see that the y value there is 2. We're all done with that. For the second derivative, that's like asking, what is the derivative of f at -3? Well, that's asking us what is the slope of the line as it passes through -3. So it wants the slope of this line right here. So I'm just going to go 3 minus 1 over -2 minus -4. If you want to simplify that down, you can. When you do that, you actually get 1. You don't have to simplify, though. That is the answer for letter B. Letter C wants to know, find the x-coordinate where each graph of G has a horizontal tangent line. Okay? Now that is where the derivative is equal to 0. That's where we have a horizontal tangent line. That's what that means. So what I'm looking for really is where f of x is equal to 0. Well, I can see two places that happens. That happens at x equals -1 and x equals +1. Now I have to state whether those are a max, a min, or neither at that point. So let's look at -1 first. This is a graph of the derivative. The derivative changes from positive to negative. So if I change from positive to negative, I have a maximum at that point. At x equals +1, it goes from negative to negative, so it doesn't change. Since it doesn't change, we have a neither. It's not a max or a min because I don't change from increasing to decreasing or vice versa. So hopefully, again, that makes sense on letter C. Letter D wants to know, where does G have a point of inflection? That is where the second derivative changes sign. Okay, so I'm looking for the second derivative, which is where the first derivative, which is basically what I'm looking for here, is I want to know where this graph of f has a max or a min. There's three different places. I've got one at -2. One that everybody always misses on this problem is at x equals 0. I do have a minimum right there. And then I've got a maximum at x equals 1, and we just state that that is where f of x has a max or a min. So hopefully this problem made sense. I think this was a good one to kind of get a feel for what's going on in general with graphical analysis. If you have any questions about this, please let me know.